Hello, good afternoon, good morning, good evening, and good night for everybody, everywhere we are watching our live. Today we start our second tutorial session from RoboCup Soccer Simulation League 3D. Yesterday we published our first tutorial session where we have shown you how you can set up a complete environment to run the soccer simulation 3D. This video is recorded here in our channel, and you can watch this video anytime when you can, and use this knowledge to set up your own environment and prepare to start your own team and join our league. Today, we will continue the tutorial session by showing you a very powerful debugging tool. When you start to develop your team, many times it will be very common that the robots don't behave exactly as you have planned. You program them to do something and they do another thing. That's very common for people who works with multi-robot systems, multi-agent systems, and especially in robotic soccer. This way, we will show you a feature that is provided by RoboViz. RoboViz is the monitor that we have shown yesterday. And the RoboViz provides a feature called RVDraw. Today, Vitor, Rafael, and Gabriel are here with me, and they will also comment something after the videos. During the videos, you are free to post some doubts. If you have any questions, you can write these questions in the chat, and we will follow these questions. And after the videos, we will reproduce, we will comment about the videos and also answer your questions. Please feel free to post questions in English or in Portuguese. We can understand both, and we can translate some eventual question that is made in Portuguese so everybody can understand the question and the answer. Okay? Hope you enjoy it. Let's go. Start with RVDraw.
Hello again. There was one. Okay.
Now, I have.
I'm gonna show you a powerful debugging tool named RVDraw. And it is an utility that allows team agents to make graphic shapes into RoboViz monitor by sending commands. So we can define many static drawings and animated drawings using different shapes and colors to represent them. How you can see, I have many things happening on my screen at this exact moment. Many drawings are descending to RoboViz monitor. We have animated points, float spheres, circles, some lines, and filed mark lines. Then all of this is possible by the RVDraw. It's really beautiful, but how does it work? So the drawbridge process happens in two steps. Okay. First, draw commands are built using the method defined in the RVDraw class. Then the agents send these commands to RoboViz to a predefined port, and usually RoboViz uses port 32,769 to receive draw commands. But you can change the port value by modifying the RoboViz config file. So I can open the file and change the drawing port value. It's very simple. And where can we find the RVDraw's basic files? So we can find the files needed to implement the RVDraw utility in the RoboViz project and some basic teams code. So in the RoboViz project, the RVDraw example code is divided between two files located within the examples folder. Okay, so in the first file called RVDraw, the methods that build the draw commands to each shape are defined, while in the second file, RVTester, the previous methods are encapsulated by methods that send draw commands to RoboViz through sockets. Okay, as you can see here. Okay, so both files have versions in C++ and Java. So now we're gonna see methods of RVDraw to build the shapes draw commands and how they can be implemented and applied by teams. Okay, so let's know more about the RVDraw methods. So by default, the RoboViz handle circles, lines, points, polygons with arbitrary vertices, number, and text annotations. The methods that build draw commands for these shapes receive some parameters that define the shape's position, size, color, and label. A name tag as a label. So each method puts the shape characteristics in a buffer using a pattern that will be understanding and translated by RoboViz. So the base methods are choose available in the RVDraw file in RoboViz project, and they are responsible for building and returning a buffer containing the draw commands to be sent to RoboViz. And regardless of the shape to be displayed in the RoboViz, there are three common parameters used by our draw command builder, and they are a color, a buffer size, and a tag or set name that identifies a drawing. And the color is reported as a vector of RGBA values, and the tag or set name is a simple string that identifies a drawing. And this is a very powerful property of the drawings, which allows to remove or overwrite drawings. And finally, buffer size. And the buffer size doesn't need to contain an expressive value, because the drawing methods themselves will assign a value to this variable, which will correspond to the size of the drawing command. But there is other parameters used to build the shapes. For example, to build a circle shape drawing command, you must specify an x, y coordinate, as the center of the circle, the radius value, and the thickness of the line that forms the circle, and the other common parameters. There are color, the name or tag, and the buffer size. To draw a line, you must enter two x, y, z coordinates referring to the start and end point of the line and the thickness of the line. To draw a point, you only need to specify the coordinate and the side of the point. To draw a sphere, you must specify x, y, z coordinate as the center of the sphere and the radius value. It's nice. To draw a polygon, you need to specify a vector, a float vector, with the vertices points, and the number of the vertices. It is the vector size. Okay, so to make an annotation, you need to specify the text, the annotation, the coordinate that the annotation will be inserted, and the color, name, and buffer size. But you can use the agent annotation. It's very it's very nice. It's a very method that allows the insertion of a text positioned above an agent specified by the parameter. So you put the agent number and the corresponding team. If it is the right team, the left team variable is false, and if the agent is an agent of the left team, the blue is true. And there is the method new select agent. So these methods makes an agent, marks an agent in the field with a circle around his position. So to finish, I want to show this method. Okay, this method here. This creates an empty drawing command. So this may seem endless at first, but it is a great way to clean drawings on the screen. So you can send this command to RoboViz, pasting the tag of some drawing as a parameter, and that drawing will be overwriting by an empty drawing. Then, to understand how the RVDraw can be used by a robotic software team, we're gonna analyze the Austin Villa-based team. They have a simple and organized code that will be explained next Sunday. Today, we will see how they implement and use the RVDraw. So first, as we can see, they copied the RVDraw methods to their code, like that. But they encapsulated these methods within other methods, like here, within other methods that sending the draw commands to RoboViz. And to be possible to send the draw commands to RoboViz, they make a socket. So the Austin Villa team make a socket in the class constructor method. So like here. And how you can see, there are some variations for each method that receive different parameters but do the same thing. For example, in this method, they send a circle draw to RoboViz, receiving a predefined color, and in the other method, they also send a circle draw command, but they receive this method receives an RGB values that defines the color. I can't miss to tell you about a fascinating RVDraw function found in Austin-Villa implementation. They divided the drawings between static drawings and animated drawings. So it works based on the name attribute. Then for static drawings, we have unique IDs. So static drawings have unique names that assure they won't be superwritten by other drawings, while animated drawings are constantly erased and redrawing. For example, this method makes our animated circle. So they receive a name by parameter. And in this case, this method makes a static circle. So this circle has a unique ID. Okay. So before we go ahead and see as it works in practice, we must check if the port and the monitor IP, the RoboViz IP, is correctly set. So let's check. And as we saw, the port is 32,769, and it's right. And the monitor IP is localhost address in this case, because I'm running the RoboViz monitor in my own PC. But in the Austin-Villa base team, we can change this value by the mhost parameter in the initialize script here. So, but in other teams may have a simple macro that defines the monitor port, like in the RVDraw example in RoboViz project. So let's go check it. Okay, so as you can see, the RoboViz host is the local host. We can change it and add an IP address, for example, like in the Austin-Villa script. But so we'll go to see the RVDraw in practice now. Our first and very useful use for drawings is to understand where the agents think that some object is in the road. For example, In this code, the agent will send a draw command to RoboViz asking to make a circle where the agent thinks the ball is. The draw command receives a name tag, so it is an animated draw. The drawing will be updated with the new agent's perception. And how you can see, I didn't give a color information to this method, but it works because Austin Villa has a preset color for each agent. So let's can run it. So let me run the team. Okay. And how you can see, each agent prints a circle in the screen where they think the ball is. The agent 11 will keep the ball, and the ball position will be updated, and the draw will be updated too. Was updated. In the second example, we're gonna see how static draw works. So here, the agents will send two drawing commands to RoboViz. In the first, a point will be made under the agent position, and in the second, a line that represents the agent's walk direction will be made. So, if I keep the clear static drawings method active, these drawings will be working as animated draws. But if I comment on it, they will keep it on the screen. But let's just see it on the RoboViz monitor. So let me open the RoboViz monitor and run the team. Okay. Play the game, and as you can see, the new drawings don't erase the past drawings. So we have a crazy drawing on our screen. To finish, we are gonna just see two other knives used for RVDraw. So let me just comment it to make the static drawings animated again. So the first, okay. So in the first example, we can predict an agent action. So in this case, the agent's kick target will be showing as a circle. The circle will be drawn only by the agents that will execute the kickball method. The second example is here. So it is a nice use for the agent annotation command. So I want the agents to say to me when they are gonna kick the ball and when they are waking to the circle. Then if they are gonna kick the ball, this message will appear up the agent position, and if they are just walking, the message moving to circle will appear. So let's see it on RVDraw on RoboViz. So let me open RoboViz and run the team. We don't have many crazy drawings anymore. So let's play the game. So as you can see, the 11 agent will kick the ball. So he is the closest agent to the ball, and the others will only move it to the position. So they are only just walking. So I can print the target, the kick target too. And a last trick is a drawing manager that RoboViz have, and you can open it here. So let me show it for you. So 1 minute. Just here. So you can control the drawings, and you can turn off some drawings. It's a powerful, a very useful tool too. Okay, it's that. So as we have just seen, the RVDraw utility is a powerful debugging tool that allows to abstract complex information and understanding our team better than reading only log files only. So thank you for watching.
Okay, so as you have seen, this is a very powerful tool provided by RoboViz. You can see during the game you are running, the game you are watching, what is happening in the mind of your agents. This is really a very good tool to trace strategy. This is the main point that Professor Demis has said us here in the comments. It's really a very useful tool to trace what your agents are trying to do. Because when you are watching, many times you see a behavior that you don't know why the agent is performing that behavior. Of course, he is performing that behavior because you have programmed it as somewhere somewhere in your code. So you need to find where is the point, where is your bug. I can tell you about an example that we used where we used this tool during a competition. For example, in the last Brazil Open, RoboCup Brazil Open competition, uh, in the first rounds of the competition, our teams were experiencing some difficulty to win matches from other teams that we usually win, and we have realized when were watching the logs of the match in the preliminary rounds that many times the teams were stopping their players in front of ours and wait for our player to collide with them and be charged by a foul. So we need to debug all our walking engine, our walking system to detect where is the problem, the bug that makes our team to collide with other players and be penalized by a fall, being deemed out of the field. And we checked that there were a very old comment that was put there, where we have removed the avoid collision condition many years ago, when there is no false systems in the simulator. The false systems were introduced 3 or 4 years, I think, ago. And before that, there was no false. Players were allowed in the past to collide each other with no falls, no penalties. So we have removed our avoid collision system in that time, and after that, we have never remember to add it again. So during the LAR competition, during the Brazil Open competition, we have used the RVDraw to trace this behavior of the agent and to find where was the problem and to see, oh, we need to turn on again the avoid collision system. So we have a very simple change that was made during the competition, and our teams became to be more present a better performance and went to the final, and we are champion for the eighth time in the Brazilian competition. We have a question here in Portuguese. Diego Assis is asking how the process of identifying the best play is made during a game. Do you want to answer, Victor?
I can try. It is a complex question, and I think he want to know how the agent know that he must kick the ball, and I'm gonna try explain that. So it's like that. Each agent knows his estimate position and the other agent estimates position. So in the team code, we made an code and algorithm. You can help me. Okay, so algorithm that say that the agent that is most nearest that the ball will kick the ball. So I know that if I am an agent, I know that I am near the ball that my colleagues, that the other team's agent. So I know that I must kick the ball. So I only code an algorithm that say that each agent that will be kick the ball must send a command to the RoboViz to print the ball position or where the agent wants to kick the position.
Okay, as we are in an international tutorial for people from many places in the world, you have received messages yesterday from people from Australia, from China, and everywhere in the world. The official language of this tutorial is English. For this reason, although we can receive questions in Portuguese, but we need to answer them in English. I can also complement what Victor has said. The main challenge in a robotic soccer team is exactly to do what you have asked us, is to decide what is the better play to do everywhere. Victor's research project is about this. He's working with some a set of algorithms and machine learning strategies that will help our team to choose the better coordinated strategy that is a set play, what we call a set play. And we are working to compose a very large database of set plays and add a machine learning strategy that will help us to learn when is the best situation to use each set play, to use each play. So that is the main research goal of Vitor's project. Many teams around the world work towards this goal to try to find the best play, the better play, and not only the best skills or movements. Some teams work more, as I said, yes, in the lower part of the agents, the control and skills, learn the better kick and the better walking strategy and the best movements. But other teams work more in the set plays, in the coordination of the multi-agent systems. And many teams work in both areas of research, and it's a very challenging framework for this area of research. Okay, I hope we could answer your question. Sorry for we cannot answer it in Portuguese. Okay, if you don't have any more questions, we start now the second part of our uh, uh, presentation, the main topic of today's tutorial, that is how you can run the full environment using one single computer using Docker containers. So you explain a brief description of what is Docker and how can you install Docker, and then we comment with you how it can support the RoboCup environment, the RoboCup simulation 3D environment. Okay. Let me put another exhibition here.
Hello everyone, my name is Gabriel Souza, and in this tutorial I'll show you how to build and run the soccer simulation 3D environment using Docker. So, what is Docker? In simple words, Docker is a platform that enables you to create containers. These containers work as virtual machines, but are far lighter and use way less resources. Let's put it like this. You have your operating system, and installed in that OS you have some kind of application to build and run virtual machines, right? So each of these machines have their own operating system, its own share of memory, CPU usage, and hard drive capacity. And usually it's way more than they actually need. So in the end, you're wasting resources. Now Docker operates using the same kernel for all of these virtual machines, or containers in this case. So all of them share the same RAM, CPU, and hard drive. That way it's not just making a better use of hardware, but the container itself is also smaller. And in case you're using a licensed OS, you don't have to buy a license for each machine. But how am I supposed to use it to build and run the soccer environment? And why? Well, since we're basically working with virtual machines, that means that anything I build here, I can save an image of it and send it wherever I want. And as long as there's a Docker installation there, it will work the same way it works here. So whether you are on Ubuntu, CentOS, even on Windows, if you're running Docker on your machine, this environment is going to work for you. Okay, so how do we install it? There are a few different ways to install Docker, but since we're focusing here on the RoboCup environment, I'm going to show you how to install it on Ubuntu 18.04, which is the current official OS for the competition. You can also install Docker on Windows. That version is called Docker Desktop, and its installation depends on which version of Windows you have, Home or Pro. If you want to know how to install it, I'll leave the link here. Their documentation is pretty easy to read and understand, so you probably won't have any trouble. Okay, so as I was saying, I'm on Ubuntu 18.04, so let's get started. Okay, so the first thing I want you to see is this. I wrote this guide so that my colleagues could install Docker on their machine. And I'm gonna use it here too, so you can pause the video at any moment and take your time to follow through these commands. The first bit is for the ones who already have Docker installed and might want to make a clean installation. So as I said before, feel free to pause the video and check the commands. Since I've already uninstalled Docker on my machine, I'll skip to the next part. This whole process, even if you have uninstalled it first, it's really short, so just follow these steps. First, as many of you might be already used to, update the applications package. So sudo okay, then install docker.io. Okay, so now the core component is installed, but we need something else, and that is Docker Compose. So if you don't already have it, install curl. Okay. Then use it to download the Docker Compose binary. And finally give it permission to execute. Now the third thing to do is to add your user to the Docker group, so you don't have to use sudo every time. For this change to take effect, you have to reboot your machine, so I'll do this real quick and cut the video. Okay, so I'm back. Let's see if it worked. Yep, here it is. Now let's try to run a container. So everything should be working, and to test I'll run the hello world image. Just type docker run hello world. So what's happening here is that Docker couldn't find the image locally, and it searched and downloaded from their registry, which is Docker Hub. I'll tell you more about it in the next session. And there you have it. Docker is working fine.
Okay, so we have saw the first part of this presentation. We have presented the concepts of Docker. Docker is a framework, a tool that is being very largely used by software development teams. So it's better for you to prepare an environment that has lots of dependencies from libraries and specific operating systems versions and any other things. So you can run it on any machine, any computer with any operating system. You can prepare a Docker environment, and you can run all your 3D simulation, as we will show in the next presentations, in a Windows computer, in a Mac OS computer, and another Linux distribution computer, different versions of Linux, of Ubuntu, and kind of thing. The second main advantage is that, as Gabriel has explained, instead of prepare an independent, complete virtual machine, as we used it to do in the past, using some virtual machine environments like VMware and virtual LAN and other kinds of virtual machine softwares, it reuses one unique image to feed all the containers. For example, if you prepare a complete environment for 3D simulation using Ubuntu 18.04, the Docker will have only one image of the Ubuntu operating system, and it will reuse this image for all the containers. So it is too much soft than have 4 virtual machines running in my computer. So I can replicate the official environment of a competition with 4 computers or 3 computers running Docker and using my host computer to RoboViz. That generally is better. I will explain why in a few moments. But and you can have it with a very softer structure, consuming less CPU and memory from your host than if you started the 3 virtual machines, for example, using VMware or any similar software. There is a question here. Do you want to answer, Gabriel?
You unmute the mic. He asked if there's a package delivery system, right?
Yeah.
I'm not sure if I can explain this because I don't have in my mind the idea of packages delivery system right now. So
I think that the idea, I have understand that the question as it's a system to deliver some package. For example, as we will explain later in using Docker Hub, you can use Docker Hub to deliver some package, some closed package with image to be run. I think.
Yeah, in this case, yeah, it is. I will even compare that the Docker Hub is essentially the same thing as the GitHub, for instance. If you want to upload your images and have them shared between multiple systems and contain and work environments.
Yes, but the difference is what you deliver in the Docker Hub, as we show later. We show later is not virtual machines, containers. Containers is like virtual machines, but is softer than virtual machines. You don't have a complete OS structure in the containers. one point that we can observe when we start to work with Docker is that the operating system image that it installs by default is a very thin image. You have almost nothing installed on it. For example, if you want to run VI, it's not there. If you want to run Nano, it's not there. Many very common packages that default installations of Linux general includes is not included in the image of the operating system that is put in the container. You need to add only the dependencies, the libraries, the software that you need on that container, so you have a very thin client in this container. For this reason, it is very it's so software, so easy to be run and also to be delivered in a package delivery system, because they are very clean images, very simple images. It also helps us to avoid some problems like the one that Romero asked us yesterday with problems with libraries, etc., because your container will be set up exactly as you need it to run, with all the configuration, environment configuration, etc. So even if you change your computer, your host computer configuration, you will not damage that environment. That environment is still working fine. It's very good to separate a very specific environment from your common use. Sometimes you use your workstation, your laptop or your workstation that you use many other stuff, and install other softwares and change the environment many times. And when you go to run the simulator, the 3D environment, something is not working, something is broken, some library is not being found, and you waste lots of time with that. If you prepare it as Docker containers, we can run the complete environment as we show in the sequence, and in the one single computer with a better performance than that we showed in the first tutorial yesterday. And we also make it isolated from the changes in your host environment, in your operating system, libraries, versions, and the other things. So you can be confident that every time you need the environment working, it will be working because the containers will be isolated for your computer. So you have some main advantage using that. We have started to worked with this a few months ago, and we are preparing all our test environment, and also, as we say in the last part of the today's tutorial, also preparing for running machine learning algorithms and other kind of stuff in this environment using containers and Docker. Okay, so we will see. Do you want to add any comments, Gabriel?
No, I believe you said it all. I was just wanted to focus what you just explained is that the main idea of Docker is just simplify things. As he said, you only need you will only get the smaller version of every OS. Essentially, just the parts that it needs to run. So everything else, it's up to you. You have to add them, and it's good because if anything gets into conflict between your installations, it's basically your fault. It's most likely your fault because everything there is set to run at the most simple way possible as possible.
Okay, I think now is that I'll put the next presentation that will continue. We have shown the concepts of Docker and how you install Docker in Ubuntu 18.04. We also showed you a link where you can where you can see other kind of installation for Windows, Mac OS, and other operating systems, other Linux distributions, and anything like that. We will talk about ports and server IPs in the following videos because we will set up here a complete network environment similar to the one we did yesterday, but without Docker. So the same thing we did yesterday in the host computers, having 3 different computers to set up the complete environment and an extra computer to run RoboViz. We will do everything here again with Docker, and at this time we'll talk about IPs and ports. Okay, let's check the next presentations, and if you still with doubts about that, you can ask again.
Now that we have Docker installed and running, we can create our first Docker file. But before we do that, I want to show you that place I mentioned, called Docker Hub. Well, Docker Hub is an online repository, or registry, for Docker, and it works in a similar way as GitHub. So you can go there and look for already built images that you might want to work with, or even upload your own. But be aware that not all of these images are completely safe. This is a public repository, so anyone can upload whatever they want into their images. My advice is to initially stick to the official images, and you can do that by selecting official images or verified publishers here on the left. I've also mentioned Docker Compose. Docker Compose is a tool that enables us to control the interactions between multiple containers in an easier way. So you can have n running containers, tell Compose what you need these containers to do, and let it take care of how they communicate with each other. Now going back to Docker files, if you go to the official GitLab of the Docker server, the same one you've seen in the previous tutorials, there's already a file you can download and build for Docker. Even though it hasn't been updated in a while, in order to make this easier to understand, I'll use this version as a starting point. The file is located here on the RCSS3D Docker into the RCSS Server 3D folder. A Docker file is like an instructions manual for Docker. It's a simple code that is going to tell Docker how to build an image and what it should have. The first command is the from. It's the source of your image. It can be made from scratch, such as most OS images, or you can give an OS to start with. Since we're running the server on Ubuntu 18.04, this will be your source. The second command is run. It literally runs the commands on these lines. So here's the place you tell Docker what you need to install on your image. In order to reduce the image final size, after we install everything we need, we run a clean command and remove the applications updated list. There's one addition I recommend you to make. just in case you'll ever need to make any changes to the server container, and that is any terminal-based text editor. I like to use Nano, so I'll just add it here to the end before the clean command. Here we set a variable to use in the next run command, so we can choose the version of the server we want. The current version we're using is the 7.3, so I'll just change this last number. Next, we have a second run command. These dependencies over here are only needed to build the environment and not to run it. So it'll be easier to just add them to a variable, and at the end of this statement, just run a remove command on it. The rest of these are build commands, pretty much the same ones you'll use if you build it yourself without Docker. For some reason that we couldn't identify yet, specifically on this version of the server, the 7.3, if we run the installation with the flag RVDraw on over here, the installation will fail. So the first change we'll make here is to remove this flag. We truly don't know why this isn't working with this specific version, but we're trying to figure this out. In any case, if any of you might have any idea, please let us know. The second change will be adding this line over here. I'm gonna copy it from my little script I have here, and we'll be adding to the, I think this is a good place for the remove command. Okay, good. This will change the agent sync mode from false to true, so you don't have to change this every time you start a container. The last thing the file does is it sets the library path inside the environment. And finally, since this is going to basically work as a binary, we'll use the entry point command. This tells Docker that anytime I run a command based on this image, the first thing it's going to do is run this command line. So every time I start a container, it will automatically run the server for me. Now that we made these changes, the changes that we needed, it's time to build the image. And for that, you're going to type the following command: docker build -t, so you can place a tag, whatever tag you want. The name of the image, in this case I will name it RCSS server 3D, colon, and the tag you want to give it. If you don't give any tag, if you don't write any tag here, it will automatically label it as latest. But since we're doing a tutorial, I'm gonna label it tutorial. And the final place is the address where the Docker file is. Since I'm already inside the folder that the Docker file is, I'm just gonna place a dot here. And let's do it. Now, this is going to take a while, so just cut the video again, and I'll see you at the end. Okay, so building is done. Let's check our Docker images. There you have it.
Okay. So the second part, Gabriel showed us how you can prepare one container to run the SysPark and RoboCup soccer server. That part that was shown yesterday by Rafael when he installed the SysPark and then installed the soccer server. Gabriel used already existing Docker file. The Docker file is a test file where you set up all the configurations of your container, of your environment. In the Docker file, you say the operating system you want your container to run. You say what libraries want to be installed, what software wants to be installed. You say the configuration for your environment variables, and you set also where are your binary files, in this case the soccer server file. In this example, the container preparation in the Docker file includes doing a git clone from the GitLab repository and download the source code of SysPark and the RCSS server 3D and compile it, make the CMake, and after that make, and after that make install. All the step by step that Rafael showed yesterday is present in that comments and that commands in the Docker file. So when he runs a Docker build, what the Docker does is to prepare that environment. So it runs that commands and clones the server inside the container, install the libraries, the dependencies, and compile the server and do a make install of it and prepare the environment to run the server when it is executed. So when the build finishes, it is ready to run the environment. If you do not change the container, the contents of your Docker file, it is ready to run the server anytime you want. When you do a Docker, the name of the container up, it will start the container and run the server. So we have the server ready to be run at this time. So this is one single example to prepare only a single container. Okay? Only the server is prepared in one container. The idea is exactly what them said in the comments, that you prepare the container, prepare all the setup of your container, and you save a binary image of this container. This container is saved, that image that Gabriel showed as Docker images in the end, and he highlighted the image that was generated, is a binary image that is stored in a special folder managed by Docker that is local in your computer. If you move this image to other computer, the binary image, you do not need to perform all this step again. You won't need to do a Docker, the name of image, and up, and it will just run. You can move it to other computers and just run, as we show later. So you do not need to build again the environment in every computer where you move this image to. For example, I can move this image to Windows computer now and just run my server in Ubuntu 18.04 inside the Windows computer as a host. So that's the kind of magic that Docker does, but it's not a magic. It's just a very intelligent architecture that they develop. They have built to run these environments. Gabriel also showed something about Docker Compose. You saw in the image that the Docker Compose is a way to make different containers running in the same host computer and communicating itself. So it answers the question of the Nego Assis. He asked about the server IP and proxy when the computers communicate itself in containers, different containers, but inside the same host computer. So as the Docker Compose will be used, and Gabriel has explained the concept, but he will show in the sequence how you set up the Docker Compose. It will create a virtual network between the containers. It's an isolated network. It's not part of the host computer real network. It's a virtual network that communicates only the containers you are running in your host. So the computers can communicate between each other. The containers can communicate between each other using Docker Compose. And as Docker Compose is easier to set up than IP network, you don't need to worry about IP addresses. You only just say the name of the container, and the Docker Compose you translate each to internal IP addresses, and you don't either need to be worried about that and what are the IP address and such kind of things. That the ports use the same ports you use in the same configuration we showed in the first tutorial yesterday. So use the same ports for clients, for proxies, and for RoboViz and other such of things. But you use a name of the container. So Docker Compose, you understand that that name is a Victor IP address, and you translate it for you. You don't need to worry about that. Okay? I hope you have answered the question about the network, and we will see this in practice in the next presentation. If you have any questions about the Docker container, you have prepared one Docker container for the server. Now you continue and prepare containers for the clients and the Docker Compose to make everything working together. Okay? Let's see it.
So we have our server image. Let's build the binaries images. I've already prepared a folder with a few binaries to make this faster. These Docker files are pretty much the same. They're all Ubuntu based, and I'm only copying the files from each folder into the root of each image. And finally, there's a bash command to run the binary into the server container. To build those images, we use the same command as before. So let's do a docker build -t. The team name, I'm gonna do Austin first. And the tag tutorial. And the Docker file directory, which is ut. Yes. Okay, so let's do the same for the other one. Okay, let's check Docker images. Okay, here they are. Now, this last bit is quite simple too. You should create a file called dockercompose.yml, and this is how you'll make the containers work together. Be careful with the indentation though. It's just like Python, one line out of place and everything stops working, so just pay attention. Okay, so you should set your services. Each service is a container. So the first one we have is the server 3D. And for that one, we use the image we've previously built. Make sure to bind the 3200 ports. What this will do is bind the container's 3200 port with the host machine 3200 port. We do that in order to make RoboViz work. And as for the binaries, just give them a name and set their images. Now we're pretty much ready to run the environment. Okay, so in the terminal, go to the dockercompose.yml file folder and run the following commands. Docker compose up, so that it will start a container, -d, so it will run a detached mode and give me back the control of the terminal, and the name of the service that you want to run, in this case RCSS server 3D. Great, server's working as you can see in RoboViz, and now we can run the teams binaries. So docker compose up -d h foot. Okay, let's wait for the whole team to enter the field, and then we can run the other one. Okay, 11 agents online. Let's run the other one. Austin. And there you have it. The whole soccer environment running inside containers. Of course, my machine is not that fast, so it will mostly look like a slide presentation, but it works. If you have a better machine than my own, I bet your server speed will be a lot higher than this one. So now if you want to end the simulation and stop all the containers, you can just write docker compose down, and it should stop every running container. at least the ones that are set in this Docker Compose YML. If you're running a container outside of the Docker Compose system, that command won't work. You have to do another command.
Okay, so we finished this part of the presentation. As you have seen, Gabriel has showed you how to build a Docker Compose YML file. The Docker Compose is another text file that prepare all your network of containers. That's the mean. Before that, he prepare the individual Docker files for the binaries of the teams. Yesterday I showed you that in the RoboCup archive repository, you can download the binaries of teams that competed in the last official competitions like Brazil Open and the RoboCup 2019 and the Offenburg tournament in 2020 and the other recent official and non-official competitions, Portuguese Opens and such kind of competitions. If you want to run older binaries, for example, if you go to competitions in 2016, for example, the binaries that are available there are binaries that run on Ubuntu 16.04. You can run that in Docker, just change that initial command in the Docker file, putting a from Ubuntu 16.04. So you have a container from Ubuntu 16.04. You can run older binaries that was compiled for older versions of operating systems. So the client binaries are easier to be prepared because they only need to copy the binary, that binary that you download from the archive repository. If you are talking about your own team, you compile your team, generate the binary files only, and put that on a folder, put a Docker file in that folder, and you say that copy command that will copy your binary file inside the container. And when you build these containers, it's very quick. It's only copy your binary inside the container. In the container, you say the operating system is Ubuntu 18.04, so we have no extra problem. The containers for the clients are already prepared, and then you prepare a Docker Compose with all the containers you want. You can, for example, this Docker Compose IML that we put here in the link that you see in the bottom of the screen. It's a Docker Compose that is more complete than that Gabriel has showed you. It contains many binaries of all teams. You have one container for each team. So using this container, it also has Magma proxy prepared. The complete environment is prepared in this Docker Compose. And when you use this Docker Compose, as we will see in the next videos, you can download all the image and run the complete binaries and server and everything in your computer in few minutes. It wants the time to download everything, and it's a very short time. So you can prepare, for example, one container for each team. We have 6 or 7 different teams in this file, and you can prepare one like you have. If you do it in real computers, you have one computer with each team, and one computer for the server, and one computer for the RoboViz, and you have many computers in your hand, so you can run any matches you want using this setup. Okay, so it's public. You can just git clone this repository that has this file. There is a README file teaching the basic steps, so how you can do this. You can use this file to run a complete environment, and we see some of these tips in the following presentations. Okay, if you have any questions, please feel free to ask. Another point, I think this last presentation has already showed it. In the container that run the server, not in the Docker file, but in the Docker compose.yml, you saw that Gabriel put a port command to tell the Docker Compose that the port 3200 on the server container should be mapped to the host computer, the computer where the complete Docker infrastructure is running over, uh, as the 3200. Why? Because we chose to run the RoboViz in our host computer, not inside the Docker container. Why we made this choice? If you look in that previous link in the GitLab repository we have showed you before, there is two repository, one for the Docker server and one for the RoboViz to try to run RoboViz inside a Docker container. Although RoboViz to present a good presentation in the monitor, it generally needs a graphic board, general dedicated graphic board that most onboard graphic cards are not enough for RoboViz. So generally need not a too expensive graphic board. Any 1 GB or 2 GB graphic board, dedicated graphic board, generally is enough. But if you try to simulate this inside a container, you need some extra preparation to prepare your container and install some extra Docker software to prepare your container to run, for example, Docker NVIDIA, if you want to simulate NVIDIA. If you simulate other computer, but you not only need to simulate, you must have an NVIDIA board in your computer, and you make the Docker container map its internal virtual graphic board to your real NVIDIA graphic board. So you need to map each to your graphic board. If your graphic board is not an NVIDIA, you need to map to your specific graphic board, and it's a little bit complex. As you have the most part of the stuff running inside the containers, I can stay free to run the RoboViz in my host computer and just connect in the 3200 port inside the container in the server container. For it to having it work, we need to say in the Docker Compose that that port of that container, specific container, will be exposed to the host computer as the same port, 3200. We could also map it to another port if you want, if you need. But this is the way you need to proceed to map a program running in your Rust computer to connect to a TCP port or UDP port inside the container. You need to explicitly put this mapping in the Docker Compose.yml. Okay? Have I missed any information, Gabriel?
No, you said pretty much everything. I just wanted to add something, is that you can run the whole environment without using the Docker Compose, but it's a lot harder to do. It's just simpler to use the Docker Compose. It was built for this. It's the purpose of the Docker Compose itself. Create these connections. If you want to use a server without Docker Compose, I can tell you how to do it. It's just you have to use the Docker run command and use a -p flag to say the ports that you want to bind. The same way it was in the Docker Compose YML file 3200 :3200 and the Docker container, the Docker image that you want to run. But it's way easier to just use Docker Compose as I previously showed.
Okay, we prepared this tutorial not to show everything about Docker. We are showing the easier paths to use Docker to run the RoboCup 3D simulation environment. That's the main goal of this tutorial. Our goal is not to have a complete Docker tutorial here. We only are showing here the shortest path, the easiest path to prepare everything to run RoboCup soccer simulation using Docker. Okay? Let's see our next presentation, almost the last.
In this tutorial, I'd like to show you that you can build the whole environment on a single image too. And that is especially useful if you have access to a high-performance computing environment, or if you possess a very hardware-wise expensive machine, a really powerful machine. In that case, you won't be needing Docker Compose because you'll run the whole environment in a single container. I've already prepared the Docker file, so I'm just going to talk about the changes that I've made. As you can see, this is a pretty big Docker file, but I'll try to explain the most significant changes that we've made. First thing we did was adding JDK8 to the first run command, so we'll be able to run the Magma proxy. Second, we added some commands to rewrite the files we needed in order to enable some features that will be very useful in case we want to run optimizations using this environment, such as reducing the monitor logger step to make the logs look better, disable real-time mode so the server will run at its maximum possible speed as fast as the hardware can run it, and enable automatic kickoff so the match can start automatically and we don't need to interact with the container. Some of these changes are still being tested by our group, but the general idea does work and we can run matches in that single container. We're just figuring these minor details out yet, but I can say it's very promising. For now, I'm just going to build this environment and show you what it looks like. So as I said before, just run the following commands. Docker build -t full inf tutorial. So as the first server build, this is going to take a while, even longer than the first one. So I'll do the same thing. I'll just cut the video and I'll see you when this is done. Building done. As you can see here in the Docker images, this one has a considerable size when compared to the other ones, but it's still small when you think about the amount of space you would waste if this was built on a common virtual machine. And besides, if you upload this image to Docker Hub, their compression system is incredibly good, and the size can get to about a third of what you're seeing here. Okay, so now we're going to run the following command to create a container and jump into its terminal. Docker run -it, so it's interactive, full inf tutorial, and the command I wanted to run, which is bin bash. And here we are, everything in a single container. And that's pretty much it. Thank you all for watching, and if you have any questions, please feel free to ask.
Okay, this was a short part. This part we are showing you an experience that we had in the later months. Our lab, we have access to a supercomputer in partnership with Senai Cimatec institution in our town, and when we was trying to prepare an environment to run in that computer, we have an access to a terminal using SSH, but the operating system there is not Ubuntu, it's another Linux distribution, and we have no admin access, so we needed to download and copy together with our environment all the libraries and dependencies for the server and all the environment, and to export the LD library path, and we have lots of work to prepare the environment so we can run the simulator environment in that supercomputer. It's a very powerful computer, so you can run everything in only one node, because you have a node with about 8 CPUs with tenths of cores each CPU. It's a very powerful computer. You can use it for our experiments. So you don't need to split in 4 computers. You can run everything in one computer when you run there. We are planning to use in the next months this computer to run machine learning in several of our projects. Many of our projects crazy process, we are in the step that we need to run some reinforcement learning strategies, and we need lots of CPU power, and we use this computer. So we have realized that we could prepare a complete image in Docker with all the dependencies. So we cannot need to prepare all these dependencies in the section of the computer, and we can prepare everything in Docker and just move to there. In this computer, they does not use Docker, but they use what's the name, Gabriel?
Say it again.
The name of the Docker counterpart in the supercomputer?
It's the singularity.
Singularity. Yeah, I always forget this name. I don't know why. I always remember that it's ends in this same suffix aty, but I never remember the initial part. But it's singularity. The singularity is another source. You can look for it in Google. You see it's very similar to Docker, but it is customized for high performance computing. So it's customized to run with lots of CPUs and lots of cores, and also to run in a high performance computing. But it has a very important feature that it's very similar to Docker, and it also is compatible to Docker containers. So I can import a Docker container to a Singularity container. So what is our strategy? We prepare an image like that Gabriel has already shown. Uh, Only one container with the CSpark and Docker server, Magma proxy if you want, clients, binaries, everything in that container, and many clients. So all you need that, and then you prepare this unique image, generate the binary image, and we just publish this image, for example, in Docker Hub, and go to the supercomputer, and you can download the image and convert it to the Singularity image. So you have the similar image in the supercomputer, and you can run your experiments, make a script, and make it run 1,000 matches against each opponent team, and you can collect many statistics, and you really do a very more serious research and use more serious data in your research to have better conclusions. You can run a very large amount of epochs in your training strategies during machine learning strategies, and you can make lots of powerful computing during your preparation and your training of your team. You also useful to test the team. Instead of run 2 or 3 matches and say, okay, I think it's okay, and let's see the competition, you can run really a lot of matches against lots of different opponents, and see how is your statistics against that opponents, and see if you really are increasing your team performance or not, and you have more trustable data. We can try to use it also if you not have a supercomputer, but if you have a very powerful computer, some gamer workstations, maybe have enough power to run using this full image with everything running in only one container. It's a kind of thing you can try, but you need some CPU power and also memory space, so you can really run this kind of full container with everything running together only in one container. So we have shown you 2 different setups, and we finish showing you the Docker Hub, how you can push images to Docker Hub, how you can pull this image back for another host computer, and we use this demonstration to show you that you can use that image that was prepared here in a Windows host machine, and you see that everything will run. We will run with complete RoboCup environment in the Windows machine, and you do not need to set up anything. You just will download the image and run. Okay, let's see it.
To show you. and I forgot to do this on the first part of the tutorial, and that is how to upload your images to Docker Hub. First of all, you're going to need an account. It's pretty easy to do. Just sign up, and then you will meet this page right here. Actually, you're going to be on this first page here. Then you click Create a Repository, and you can place a name. Since as an example, I'm going to use the server. So RCSS server 3D. Just place a name there. You can choose to have a public or a private repository. Beware that the private one, you only have access to a single private repository in the free account. But if you have any other plans here on the Docker Hub, you might have access to more private repositories. You can leave the rest as it is and just create. So now we have here a RCSS server 3D repository, and we can push our images using this command right here. But before we do that, we need to tag one of our images with this tag right here, so that it will push automatically. So let's do that. Okay, so I opened the terminal and I typed Docker images to see my images. I've already made some changes here. I've added some Binaries images so that I will make the upload, and then I will show you how to download these images and run the environment using Windows instead of Ubuntu. First things first, the image that I'm going to show you here is the Soccer 3D one, so it's this one. So for that, I'm going to type Docker tag the ID of the image, which is this one, and the tag that I want to give it. So the first thing you're going to type is your Docker ID, then the image, which I said it was this one, CSS. There's an S missing here, and I'm gonna use tutorial 2. Okay. Now if I type Docker images, as you can see here, we have a tagged image that is essentially the same image because it has the same ID. It's just a way to make it easier to understand. Now you have to log in to Docker. So Docker login docker.io. You type your username. Now your password. Okay, I had a little problem here. So let's just do it again. Docker login docker.io. Username and password. Let's just wait a bit. Okay, now that we're logged in, let me just type again Docker images. I'm gonna go Docker push and the image that I want to push with the tag. So yeah, it is the same tag, so tutorial. Okay, let's see if it worked. I'll come back here. It was never pushed, so let's just update the page. And okay, great. Here you go. Okay, so I'm gonna do the same thing to the other images, to the Binaries ones, and then I'm gonna jump to Windows, and I'll see you there. Okay, so now I'm on Windows. I don't have a webcam connected to my desktop. For the previous parts of the tutorial, I was using my laptop. But since I don't have a webcam here, you won't be seeing my face for this last bit. But as I was saying, this is going to be once again, a really quick part of this tutorial, so let's get moving. So here we have the BahiaRT Docker Hub repositories. So every repository I've uploaded in the previous part are here. And now what we're going to do is just open your text editor again. I'm using VS Code, so let's just jump to it. And just create a Docker Compose YML file. You should have Docker Desktop running, so just remember to start it up. So here, what we're going to do is just specify the services that we're going to run, and just use the images that you've uploaded to the registry. Since we're not using local images, we have to set the owner of the registries, of the repositories that we want to use, and then the name of each image, along with the tag that we want to use, if it has more than one tag. Or if we don't want to use the latest, because it's by default it uses the latest version. So now we're using the tutorial one. So this is the good thing about Docker Compose. It will automatically download every image for you. You don't have to pull each image by yourself. You don't have to do that alone. You just create a Docker Compose YML file, and it will take care of everything for you. So let me show you how it works. Okay, so we're going to use the same command as before. So just be on the folder, on the Docker Compose YML folder, and just type in Docker Compose up -d and the name of the service that you want to run, server 3D. And we can go to RoboViz here and have a look if it's going to work. So it didn't find the image locally, so it's downloading. Okay, so my RoboViz froze. When I leave it open for too long, it just crashes. So I'm going to restart it. I'm not going to stop the container. I'm just going to restart RoboViz to check if it's working. And there it is. It was just a crash. It was just a crash on my RoboViz, so it is working. Now let's just run the agents. Just resize the RoboViz windows here so you can see the code. Okay. Docker Compose up SD. How did I name it? Alston. Okay, so key Alston. Nice. Let's just wait for all of them to go in. Okay. Now let's just choose another one. Let's try MIRG. Docker Compose up SD. Let's see if it works. Be aware that not all of the binaries I've uploaded are working correctly. I just took a bunch of them and uploaded on my own, but some of them need one or two dependencies, extra dependencies to run, which is the case of Magma, for instance, that, as we have noticed, it needs Java to work. So I had to install the JDK on their image in order for the binary to work. Let's try Java. Let's try Magma. Okay, let's try play. And that's it. Working on the Windows environment. I'm using a Windows system and I'm running everything fine. Even though I'm on a desktop, my CPU is not strong enough to hold all of the 22 agents plus the server on its own. I'm using a Ryzen 5 3400G in case you want to know my specifications. But in any way, it's way better than using the laptop that I was using with Ubuntu. Okay, so this is it. Thank you all for watching, and if you have any questions, please feel free to ask.
Okay, so this was the last part of Docker presentation. We saw that in that last part, Gabriel showed you the Docker compose.yml file that only specify the image in Docker Hub. This is the Docker file that I have previously published the link here. If you download that Docker Hub from our Git repository, you can reproduce exactly what Gabriel did here in Windows or Ubuntu or Fedora or any other operating systems you want. I think even in Mac OS, if you install Docker in Mac OS, you can also run it there. So you can run the complete RoboCup environment using this Docker Compose file that we have turned publicly available for you, and run all the teams. You saw that some images may be not running. The MIRG team that is maybe it's missing. I think that this image is missing export LD library path to some library in his local. We can, when we detect these bugs in any image, we will update these images in our Docker Hub, and in the future all images will be working. But at this moment you can run lots of teams. You can run BahiaRT, you can run UT Austin Villa, Magma. All these teams are working fine. You have many teams to run, test the environment, and check it working. And also you can develop your own team. About this, I want to show you some final information. You can see here in the soccer scene website, this is the call for participation for RoboCup 2021. This year, the RoboCup will be a worldwide competition. It don't have a specific host city, because it will be a virtual competition. So we do not need to travel to anywhere to participate in the world competition. The competition will be held from June 22 to June 28, but the call for participation is open up to May 2nd. Okay, so we have almost 1 month to prepare qualification materials. You say, what is the qualification materials? The qualification material is three things. One, team description paper. Use this format here, Springer LNCS. It's at least 4-page paper and the maximum of 12 pages. You don't need to describe contributions or results of your research, but you can describe your proposals. Especially if you are a new team, you can write a TDP describing your proposal. I want to join this league to develop such kind of proposals, and I will be using a base code from Magma or from UT Austin Villa, or I will develop my own team from scratch. You can just write your proposal. Okay, you don't need to present results. Of course, the older teams in the league also have results to present, but the main idea is to describe your proposal, the proposal for your team. Okay, if you have any previous publications and achievements on RoboCup Symposium, or not necessarily related to 3D simulation, but any other participation in RoboCup community in other leagues, for example, people from 2D simulation have previous participation in RoboCup competitions and in local competitions like Brazil Open and Portugal Open and the other competitions in 2D or humanoid or SPL or any other league, and also publications related to your research in RoboCup Symposium or other conference or journals. You can just put a list of this in this file, and the third, a binary of your team as it is at the moment you make your submission up to May 2nd. So you can watch the tutorials 3 and 4. You at this time you already know how you can prepare your environment. You make it your environment ready to run test with the binaries of other teams. Or say my environment is okay, it's running. On Saturday and Sunday, we see two options of source code teams that you can use as a base. These source code teams are teams that works. If you put the source code teams, compile and run these base teams, it is the players walks, get up, the players kicks. They don't deliver their best kicks and their best walking. Everything is not optimized to their best, but they are working teams. So you can make very few changes in the team just to put your own option in the decision, or you can try to optimize a kick or do anything you want, or try to take decisions, different decisions. When they try to kick, you change. No, you not kick, you dribble the ball to the goal. You can change the decisions and make such kind of thing. And with little changes, you have a binary to submit to the competition. So it's a very special condition to participate in the competition. It's easy to submit your participation. You have time to do this because you don't need to make lots of change in the basic codes, certo? But any change you make and a very good description in the TDP of your plans to the future are enough to you be accepted in this league. Newcomers are very welcome to this league, especially in this year. You do not have trip costs to go to RoboCup. It will be completely remote. And after that, you can continue participating in other regional or local competitions. For example, in the end of this year, in October, almost October, we have Brazil Open that have a 3D simulation. You can take part of Brazil Open. We also announced this in this website. Another important thing is to see in this site is that the main point that we should try to get information is the mailing lists. We have two mailing lists. There is a general mailing list for Soccer Simulation League that are both for announcements and subjects related both to 2D and 3D simulation. But we also have a specific 3D simulation list that is more dedicated to technical questions about 3D League. So if you join this mailing list, it's not a list with lots of messages per day, but people in the community are very friendly. And if you post specific doubts, technical doubts, even newbie doubts, doubts from newcomers and new teams are very welcome, and people will answer you and help you. It's very good to join the list because you have people from all teams in the RoboCup community there, and you can ask to anyone about your doubts, and people will be very pleased to answer you. Here are the source codes. On Saturday, we will see about this code, Magma from Brewery. This code was just released 2 weeks ago, I think. So it's a very fresh code, and the people from Magma from Hamburg will talk about it in our tutorial session 3 on next Saturday. It will be held at 1 p.m. on UTC time. Okay. And on Sunday we will see the UT Austin Villa base team that was released on 2016. And this team was the base of the team that won the 2017 RoboCup. Here is the repository. The codes are already available. This code is in C++. The Magma code is in Java. You can use any of these codes to start your team. It's very easy. I think that using the information from the 4 tutorials, in 2 weeks you have a working team. And you have a working team different from the base teams with something that you have added to the team, that have your own mark in the team, and you can use, oh, this is my team, it's not more of Villa or Magma. I have made some change that it has my own mark here. Have previous releases of codes here, but most of these releases should not work in recent versions of server. But these last two ones are working versions that you can use, and you have two tutorials to see the explanation about this made by the authors of these codes. Okay, so it's a very important source of information. You can clone these repositories and start to see the codes before the weekend. And during the weekend, you can arrive in the tutorial sessions with doubts about this, and you can ask doubts about this. Okay. We also want to show you. Let me see. Yeah, here you have also a forum. If you go to, I think it's it opened. It opened a new window. If you click here, you have a forum. It will open a new window. You can register to this forum. Is also another point to join the community and ask questions and get information with the community. And the last, before I leave this site, let me see here. The tutorial sessions. This is the tutorial session 2. We have finished now. The next tutorial session is on April 10, on Saturday, from 1 to 3 p.m. on UTC time zone. It will be held in this link in the Zoom, and after the session, they will turn the record of the Zoom meeting available publicly. But it's very special, especially on this kind of tutorial, because you can download the code before and see the code and have more specific questions to join on live this session. And in the next few days, we also put here the link for the last tutorial session on April 11, in the same time as these tutorial sessions, from 5 to 7 p.m. on UTC time zone, to see also the code from Austin Villa in C++. You can also check the code before the session and have lots of notes and questions during the session here. Okay? To finish, if you go to the 2021 RoboCup website, you can see here in the registration process and fees that this year the registration of a team that includes one member that is not the practice of RoboCup World Competition. Generally, you pay the registration of the team, and each member pay an individual registration fee. This year, the registration of the team includes one free member. It's only $100. And all additional members, students, are $20, and faculty or staff $50. Just to compare, in the last RoboCup 2019, in the early registration, that is the cheapest one, only the team with no members, only the team registration was $790. And you need to pay at least one extra member, for example, a student, $380. So the cheapest participation in 2019 RoboCup was more than $1,000. Now, with $100, you can register one team with one participant. So it's the cheapest RoboCup in the history of RoboCup since the earliest events more than 20 years ago. So it's an unique opportunity to join the 3D League with a very low registration taxes, and also with all this information in the tutorials that can let you really start a team in 2 weeks, and you have your own team, and you can submit your binary and your TDP and your list of achievements in the submission form, and qualify to RoboCup. Even if you think that it's too quick to participate in the RoboCup, you can also participate this year in the Brazil Open in October. You have more time to prepare better your team and arrive there with a good team. But even if you do not have a very good team to participate in this road competition, it's not the most important thing in your first participation. The most important thing is to join the community, to be together with people and exchange experiences and talk each other about your projects, about your research interest, and show what you have done and learn with most experienced people how they have been done many things that you are experiencing. So the networking is the most important thing of RoboCup. Okay, this way, if you have any further question, we are available. Gabriel, Vitor, and Rafael, if you want to say anything else to finish our tutorial, feel free, please.
No, I think I don't have anything to add. You pretty much said everything once again. So I'm good. If anyone has any questions, please feel free to ask.
Okay. Vitor, Rafael, do you want to say anything?
No. Okay, I think we have covered all the basic topics, so feel free to join us, and I hope we get many teams to play and just share the experience, as Marcus said.
Thank you. Vitor?
I just want to thank you for watching. It was a nice experience for me, and I will want to like it too.
Okay, we finish asking you to like this video so YouTube can understand that it's of interest of many people, and also share this link for as many people as you can so we can reach more people who could not be here in the live streaming, and also have the opportunity to show this content to most people, and also announce the following tutorial sessions so we can increase our chance to attract more new teams to the 3D League, and to turn this community more this community stronger, and also with a very exchange of experiences between many good research groups over all the world. Okay, thank you everybody. Hope to see you on RoboCup, and after that in Brazil Open in October. See you. Bye.